Hello, students who want to succeed. Welcome to Super Easy Physics and Mathematics. Today, we're going to be learning how to crack Cambridge IGCSE Physics, and we're going to be using the Paper 4 Theory Extended, Variant 3, May-June 2024. I'm ORISHEJE Matthew. As we are going through this paper, I'm going to be giving you basic idea that will help to cover up for the missing gap in your learning experience. So get your paper, get your pen and your calculator. Let's dive in and go through this question. As you all know, the paper 4, you are expected to answer all the questions, and the constant that you are supposed to use in this particular question is the value of acceleration of free fall. You are expected to use 9.8. Then the total mark is 80 mark. I want you to press the subscription button because you'll be glad you did. You'll be updated whenever I upload new video that will help you in your journey to success. Also, there is a new product on the channel. You have the opportunity to book an online coaching class with me personally, and so you can use this code, which will be added to the description of this video. So let's look at question 1. It's all about motion. So a ball of mass 130 gram is launched from the ground at an initial speed of 14 meters per second, vertically upward. It decelerates until it's at rest momentarily at the height of h above the ground. So what we are actually looking at is a ball is thrown upward. So you have a ball here, and then the ball is projected upward. It gets to the maximum height, and then it will fall back again. So what we are interested in finding out in this question is we are going to be looking at how long does it take the ball to get to the maximum height, h, and also we're also looking at the time and then the value of the height. So for us to be able to get that, so when the ball is projected up, you take the value of g as negative 9.8 meter per second square. So what is deceleration? Deceleration is decrease in velocity as time increases. Okay, so that is velocity is decreasing, so you have it like this: decrease in velocity. So if this is the vt graph, so this is time, and then this is the velocity in meter per second. So if you have this graph, then if the velocity is decreasing as time is increasing, so this velocity is going to have a negative acceleration. So it's a negative a. So we say deceleration is also a negative acceleration, and then a is equal to delta v over delta t, and it has a negative value. So Acceleration of free fall is 9.8. Show that the time taken for the ball to reach that height is 1.4 seconds. So if a ball is thrown up, what is going to happen is that the object, the speed, velocity will start reducing until it finally becomes zero at the maximum height. So we use the first equation of motion. V is equal to U plus G gt. So we have 0 is equal to 14, then negative 9.8t, and then you have 14 is equal to 9.8t, t is equal to 14 divided by 9.8, which is equal to 1.429 seconds. So t is approximately 1.4 seconds. So we've been able to prove that. Okay, now the next one is calculate the height ignoring air resistance. So if you want to calculate the height ignoring air resistance, there are two ways to calculate it. We can use fourth equation of motion. So let's look at the two ways to calculate it. We can use v square equals to u square then minus 2gh, or we can use conservation of energy. The kinetic energy of the ball when it was thrown is equal to the potential energy of the ball at the maximum height. So it's equal to the potential energy. So we can use this one. So let's use the first one first. So if we are going to use this, so at maximum height, the final velocity is 0, so which will become 14 square minus 2 times 9.8 h. So we have h is equal to 14 square divided by 2 times 9.8. So this will give us 10 meter. Or we can use half mv square is equal to mgh. So, and because the object that we are talking about, the ball is the same ball, so the mass is the same. So mass go off this equation. So we have v square over 2 is equal to gh. Then from here, we can say h is equal to v square over 2g. So which is equal to 14 square over 2 times 9.8. So that will also give us 10 meter. All right. So let's go to the D part of the equation. Now the D part of the equation, which is the last aspect for 3 marks, then describe and explain the motion of the ball as it falls. Explain the motion of the ball as it falls. Consider the effect of air resistance in your answer. So we are going to be looking at the motion of this ball as the ball is falling. So what is going to happen is that as the ball is falling, the motion of this ball is going to be in this way. So when we look at the VT graph, as the ball is falling, the velocity of the ball will be increasing, then it will get until it gets to the last point here. So what is happening is that this is V, and then this is the time in second. So velocity increases. So when you drop the ball momentarily, initially the ball is going to accelerate with constant velocity. Then as it's accelerating, what is going to happen is, first of all, initially the acceleration downward the ball accelerates downward at the rate of 9.8 meter per second square. Then, as air resistance increases, the downward resultant force reduces. So the downward force, that is the force that will be pulling on the ball. So this is the ball. As the ball is dropping, so what happens is we have a ball that is falling. Then initially you have the acceleration. Then the ball, this is the force that is acting downward. And then you have air resistance that is going upward. So this is the air resistance. So you have F down and the F upward. So as the ball is falling down, FD will be reducing. Then the downward force is equal to air resistance when the ball reaches the terminal velocity. Okay, I think those points are enough. So this is all that you need to know for the first equation. So next we're going to be going into second equation.